Assalamu alaikum and hello everyone. Welcome to Mathematics with Shahab Yaqub. We are going to solve a question of paper 6 popularly known as S1. This is from October-November 2013 variant 63. The question is about permutation combination and it is considered one of the toughest questions. The first part, find the number of different ways that 9 letters of the word aggregate can be arranged. So we have a word aggregate. We have to arrange the number of different ways that all the 9 letters of the word can be arranged provided the first letter is an R. So let's get started with the first part. 6 part 1, the first part. Let me write R at the beginning and this is fixed. And even before that, let me first write down the necessary thing. A, G, G, R, E, G, A, T and E. This is the first thing that needs to be done. So let me just highlight this thing and let me draw a box around it. There are 2 A's, there are 3 G's, there are 2 E's. How much is that? That's 2 and 2, 4, 5, 6, 7, 8 and 9. That adds up to 9. So now 1 R is used. How many letters are we left with? We are left with 8 letters. So the first answer is 8 factorial, but it's not over yet. We have to divide by 2 factorial for the A's. There are 2 A's over here. And at the same time, we have to divide by 3 factorial because there are 3 G's over here. And also there are 2 E's. So divided by 2 factorial. So let me recap it for you. The first R is there, that is fixed, pasted on the wall. 8 alphabets or letters are left, that is 8 factorial. Divided by 2 factorial for the A's, 3 factorial for the G's and 2 factorial for the E's. Now grab your calculator and evaluate. I have the answer written over here, which is, I think I missed it. So let's move on and let's do the next part. Now the next part is this thing, that is find the number of different ways that 9 letters of the same word aggregate can be arranged. Focus on the word arranged in a line if the 3 G's are together, the 2 A's are together, the 2 E's are together. So the key word is together, together, together. Now first of all, what I need is that I need 3 boxes. So that is the second part. And let me draw 3 boxes, nice rectangular boxes. That's the first one, that is the second one, that is the third one. Why do I need the 3 boxes? Because there are 3 G's, put them in the first box. That is 3 G's in the first box. And then what else is there? There are 2 A's, they go in the second box. And then there are 2 E's, they go in the third box. So how many are left? We are left with an R and a T. So that is R and T over here. Now what's the rule? The rule is treat the box as one unit. 1, 2, 3, 4, 5. They can be arranged in how many ways? So let me grab a white marker and they can be arranged in 5 factorial ways. Now what about the 3 boxes? What exactly is happening in these 3 boxes? Technically nothing is happening. It's just one way of arranging it. But if you persist on writing it, so let me write 3 factorial divided by 3 factorial for the G's. Let me write 2 factorial divided by 2 factorial for the A's. Let me write 2 factorial divided by 2 factorial for the E's. Why? Because they are identical. So if they are identical, they can be arranged in 3 factorial ways, but since they are identical, divide by 3 factorial. So there is one possibility on the inside, and 5 factorial I can get the answer. So this answer comes out to be 120. That is the answer for this particular part. Let's move to part 3. That is The letters G, R, T are consonants, and we know that much of English language, and the letters A and E are vowels. Find the number of different ways that 9 letters of the word can be arranged in a line if the consonants and vowels occur alternately. So that is the key word, that is alternate. Now, when we talk about alternate, we should remember this fact that alternate could come in a combination in a way that there is a difference of 1, or let me write it down, this is alternate, or equal numbers. So that can be asked for alternate also. For example, let's say if there are 4 boys and 4 girls, can they stand alternately? The answer is yes. It could be boy, girl, boy, girl, boy, girl, boy, girl, or that means add girl, boy, girl, boy, girl, boy, girl, boy. That is for equal number. There are 2 possibilities. But let's say if there are 4 boys and 3 girls, in how many ways can they be arranged? Only one way. It has to start with the boy. Boy, girl, boy, girl, boy, girl, boy. That's 4 boys and 3 girls. So now the same over here. How many consonants are there? So let me write it down. So out of this, the A is there, the A is there, and then double E, that is 4 vowels. And how many are there? Let me just write V over here. I think I'm short of space. So let me write this as 4 vowels. And how many consonants are there? 3 G's, R and T. So 3 G's, R and T, that is 5 consonant. That means for this part, so this part is basically right over here. And let me draw a box because the rest was knowledge thing. So over here, I'll write for third part, it has to start with a consonant, vowel, consonant, vowel, consonant, vowel, consonant, vowel, consonant. How many consonants are there? That is 5. So this is 5 factorial. How many vowels are there? 4 factorial. But don't forget the denominator. What goes down in the denominator? There are 3 G's. So for the consonant, divide by 3 factorial for the 3 G's. And what about the vowels? That is 2 and 2. So 2 factorial and 2 factorial over here. This is for A and this is for E's. Got the idea? So now let me just add a page so I can do some working comfortably. So 5 factorial, let me write it over here. That is 5 into 4 into 3 into 2 into 1. Just some basic mental maths. This is 3 factorial, 3 into 2 into 1. 4 factorial, that is 4, 3, 2, 1. And over here 2 factorial is 2, 2 factorial is 2. So let's do some calculation. This 4 and these 2 cancels out. I'm left with a 6 over here. There is a multiplication. And then 3 to 1 and 3 to 1 cancel out. 5 and 4 is 20. 20 into 6 is 120. Since I'm not in the mood of opening up the calculator, so I have done the calculation manually for you. So the third part is done, and that is the answer for this part. Now we are moving to the fourth part, and that is the most crucial part. So let me first write what is exactly there in aggregate. A, G, G, R, E, G, A, T and E. And let me highlight it again. So there are 2 A's, and let me fill up the box. Let me look at this thing. Required to hold snap. Okay, there is 2 A's. There is 3 G's. There is 2 E's. And then there is an R and there is a T over here. Now it's about selection. So let me highlight it. Find the number of different selections of 4 letters of the word aggregate which contains exactly 2 G's or exactly 3 G's. Now there are 2 approaches to this particular question. Let me explain you both the methods. So if I focus on method number 1, that is the usual table method. You have to list down all the possibilities. And the focus is on G's. So let me first write the 2 A's over here. Let me write the 2 E's over here. So 2 A's, 2 E's, And what else is there? There are 3 G's. So there is a G, and there is a G, there is a G, and last but not the least, that is R and T. And let me draw a lot of lines over here because the possibilities are many. So let me at least draw like 10-12 lines. I know this method is lengthy, so let me focus on this first, and then I'll be able to explain you the other method. Okay, so far so good. Now they are interested in 2 G's. So first of all, for the G, let me fix the number 2 over here. And let me just write down 1, 2, 3, 4, 5, 6 because I know it would be somewhat over here. Now let's look at a possibility in which I choose 2 from here and I choose none from here. And I need a total of 4, okay? So if I choose 2 from here, none from here, 2 from here, that means I just need 0 from here. Let me first fill it up and then I'll do the calculation. Now let's reverse this. Let me write 0, let me write 2, still there is a 2 and there is a 0 from here. Do you get the idea? Now what about the possibility I'm choosing 1 from here, I'm choosing 0 from here, I'm choosing 1 from here. Similarly 0, 1, 1. So basically you are playing with this 2, 0, 0, 2, that's like symmetry. 1, 0, 0, 1, that's symmetry. This 2 is fixed. So 2 from here, none from here, because altogether this is 4. 4 from here, none from here, 1 from here, 2 from here, therefore 1 from R and T, 0 from here, 1 from here, 1 from R and T. Now let me think of another possibility. What about there are 2 zeros and there is already 2 over here, I need to choose 2. What about there is a possibility of 1 and 1, that is 2, and there is a 0 over here. I think so far so good. I have consumed all the options. What about the option that is I choose 3 from here? And let me write 4 numbers. Let's see exactly what happens. If I choose this, that means there is a possibility of choosing, let me choose a marker, that is 1 and 0. So 1 plus 3 is 4. I need 0 from here. Let me flip these two. So 0, 1 and 0 from here. Make sense? What about the possibility 1, 0, 0, 1 is there? What about the possibility of 0, 0? That means I can choose 1 from here. I think I have consumed everything. So let me grab an eraser. Let me erase all this. And how many possibilities are there? That's 1, 2, 3, 4, 5, 6, 7, 8, 9. So let me double check. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yes, 9 possibilities are there. And now the calculation is based over here. So out of these two, you will choose 0. So that is 2C0, which is 1. This is 2C0, which is 1. This is 2C1, which is 2. This is 2C1, which is 2. This is 2C2, which is 1. 2C0, which is 1. 2C0, which is 1. This is 2C0, which is 1. This is 2C1, which is 2. I hope I've gotten everything correct. 1 plus 1 is 2, 2 plus 2 is 4, 4 plus 2 is 6, 7, 8, 9, 10, 11, 12. And I think that is the answer. So the answer for this is 12. This is method number 1. Yes, it consumed a lot of energy. Now let me just copy this thing and let me go to the next page and let me show you method 2. Maybe you will find the second method easier. So now method 2 of part 4. So this is combination NCR. Method number 2, that is we have, let me write it out. We have double A and then we have double E. We have 3 G's. We have R, we have T. So double A, double E, 3 G's, R and T. Now first of all, if I am interested in 2 G's, that means I'll just pick 2 out of here I have an A, I have an E, I have an R, I have a T. I have double A actually, double E, R and T. So what are the different options that I can make? I can make, let me write it down, AE, a combination of A and E, a combination of AR, a combination of AT, AE, AR, AT. Similarly, I can have ER and then ET. Of course, I can have a double A. Of course, I can have a double E. Of course, I can have R and T. And how many options are these? So let me count it. This is 1, this is 2, 3, 4, 5, 6, 7, 8. So 2Gs, there are 8 options so far. And we will double check it with the previous result. What about there are 3Gs? If there are 3Gs, that means I have which ones? I have a double A, I have double E, I have R, and then I have T. So now, since 3Gs are there, I just need one more letter. And of course, that was obvious in the above. Since 2Gs were there, I was forming a letter word. And since 3Gs are there, I just need one letter. So I can have A, I can have E, I can have R, I can have T. How many options are there? There are 4 ways or 4 options. So therefore 8 options, 4 options. Therefore how many is the total? The total is 12 options, 12 ways. So basically for 2Gs there were 8 options. Let's double check. This is 1, 2, 3, 4, 5, 6, 7, 8. So there were 8 options for 2Gs and there were 4 options for 3Gs. This exactly matches with this. So that was the famous question A, G, G, R, E, G, A, T, E. And the aggregate, the idea, the concept, the philosophy is that make a table, write it out, draw a diagram, do whatever is necessary, think out of the box, and that is what you learn at Mathematics with Shahab Yaqub. Stay tuned for more content.